Hello, everyone. Welcome to another episode of Reactive Lab. Today, we try to become people's browser history. Last time, we tried to test internet, and now it's time to become internet ourselves. And yeah, browser histories. So yeah. Oh, this is wrong. I should have corrected this, but this should be Webflux. Yeah, nevertheless, we're gonna create HTTP endpoints in this episode. We're gonna use Webflux Library, and which is based on the Reactive stack. And in terms of what we used to use, the one that was based on servlet stack, it's called WebMVC. Most of them are from Spring. And today, we compare them instead of comparing declarative and imperative, kind of the same, but more specifically these two libraries. So on the top, we see the servlet-based API, HTTP API creation in Spring WebMVC. So we have a request body, we have post mapping, all these annotations that you are already familiar with. And you can see that there's just a capture request, could be anything, just an example. We validate it, and then we extract some items from it, and then we pass all those items to a service. It could be anything. So it's just a flow of actions. And here we have a reactive version created by Webflux. Yeah, I don't speak much about the how, but you can see that it's reactive now. This is what you are already familiar with. So we have a flux, and then we do validation using filter, we map, and the stuff that you are already familiar with. So you see that there is the reactive way is already there in the implementation. But we're not going to talk much about implementation today. We talk more about contracts, and let's jump into it. So first, dependencies. If you want to do HTTP endpoints in a reactive way in the Spring family, you could use Webflux. It's just that, a Spring Boot starter Webflux. That's all you need. That's the one that we have been using for web client and web test client as well. How to initialize reactive web stack. All you need to do is to basically put this library into your class path for a Spring Boot application, of course. And then it basically does everything for you. And then you just need to annotate a class with REST controller. And from there on, you can start implementing and creating HTTP APIs. There's another way. You can actually expose a bean called router function with this type inside it, server response. This is the more functional way of creating HTTP APIs. It's kind of similar to Node.js style, if you have ever been exposed to that. We're not going to cover this, but it's also cool. It's kind of very functional way. But yeah, we're going to stick to the way that is similar to WebMVC. And speaking of WebMVC, most of the annotations that you already know and have you know about and have used when you were implementing servlet-based HTTP APIs, WebMVC HTTP APIs are still available here, pretty much the same. The only thing that's gonna change here is the return type of your APIs. And instead of just some classes, now it's classes wrapped within reactive types. Yeah, so let's jump into it. Let's see an example how to create a API that accepts post requests. The response status code is no content. So far, nothing new. And since it's no content, we expect no value to be returned. But in the WebMVC world, you could put just void here, simple void with the primitive void. But now we have to do mono void. So that's to make it reactive. But apart from that, you could also have your inputs, your request body received as a mono, as a reactive type. So we can actually get a request body wrapped into a mono. That makes it more reactive compared to having just request body here. Request body also works, it's fine, but this is more reactive. And then since this is mono void here, we return empty. And the reason that I brought this example here is that actually this is an example that is not the most straightforward one, but is a one that is not very clear. When you face the need to create a no content HTTP API in a reactive way, you're a little confused because you don't want to return anything, but still you need to return something in the reactive way because you always have mono or flux. So I just put here so that in case in future you face the need for no content, you know how. But in other cases, it's more clear what's happening.
Can I ask quickly about the request body and mono wrapper there?
Yeah, sure.
What does it actually mean if you I realize it's nice to already have it in a mono if you're gonna do reactive stuff, but does it also mean that the parsing of the request body is done only if you actually need it, or how does it work?
Yeah, so the exact details I don't know, but the way that I understood it is that like you can be reactive to some extent, you can be fully reactive. So this request body comes as like basically there are some bytes that will be basically deserialized into this class. So those bytes are in some buffers, and those to read from those buffers is an IO operation. You can do that operation blocking, you can do non-blocking. If you use mono, it will be non-blocking. That's how I understood it. So just having less blocking operations in your stack. But this is not common to do this because the effect is not much. But if I want to do a fully reactive application, I would do it like this. I would actually put a mono or flux here as well. It's with mono, it's a little less clear, but with a list. So if you have a big list here, I prefer a flux instead of a list. So yeah, that's another thing. Speaking of examples that suddenly at the start are a little confusing, but are a little harder to find examples around, or like similarities. Even when you face them, you don't know how to write it right away. You need to search. But I just put the example here on Errol Handling so that you don't have to search when you face the need. You can just have a look here. So yeah, Errol Handling, we have these advisors in WebMVC. And when we throw an error in the servlet stack, our advisor picks it up and then it sets the error, like the HTTP status code on it. We can do kind of similar thing in the reactive way, at least with Webflux. And let's say here we have a get mapping, and it's just bad request because of the example. It always returns a mono that contains the error, and the error is illegal argument, just some error. So when we have something like this, you see that we don't care about the HTTP code, response code here. We care about the response codes that are related to error cases in some handler methods. So we just put a simple method there, somewhere else in advisor class, for example, and we annotate it like this. Say that every exception in the flow, in the whole stack of the flow that is like illegal, if it reaches the point that is actually being exposed to the client, instead of being exposed to the client, it will be catched here, and then the response status would be bad request. This is all annotations. What is happening here in the method body, you can do some logging if you want. So yeah, that's one way. There are many different ways to play with exceptions, but this was a very neat way that I just saw somewhere. So that, okay, this is good to have somewhere as a reference. But yeah, actually, you wouldn't need much examples more than knowing these 2 points to start writing reactive APIs.